Hi, welcome to week 6 of our Intro to Programming for Business Majors. This is a course teaching Java to non-computer science majors. This last lesson, we're going to go into loops. We're going to start with the for loop in this lesson, and next week we're going to break into the while loop. So let's just jump over here. And so this is part 1 we're doing here. We're going to learn about incrementers and decrementers. The for loop, nested loops. We're going to learn about break and continue statements, and we're going to generate random numbers in a random class. All right, let's start here. Incrementers and decrementers. All right, so an incrementer is counting up by a value. Could be 1, could be 2. If I count by 5, 5, 10, 15, then I'm incrementing up. If I subtract by a value, then I'm decrementing. So this can be done by simply taking a value. You've assigned a variable with a value in it, and you say, I want that variable now to be equal to its value plus 1 or its value minus 1. The shorthand way of doing it is these pluses and minuses. So number plus or number minus, plus plus number or number plus plus, number minus minus number. What this does is this says add 1, this says minus 1. So this only increments by 1. So and we can go ahead, if you want to take a quick peek at it, we'll pop over into here and we can bring up the incrementer and we change the view. Oops. Sorry. Get this back in. All right, so we start with 4 and print out a number, and then it's going to increment, and then the number should go up. It's going to increment again, and the number should go up again, and then it's going to do minus. If we run this file, you'll notice this run anyway comes from the fact there's like some bad code in the library, so it's just warning me. But now we go ahead and look down, and we've got, I will start at, number starts at 5, then we did the increment up once, gave us to 5, went up next time, went to 6, then we did the increment down, so it went back down to 5 again. So again, if you quickly looked, it was just, sorry, hold on. Get the screen in order. All right. So again, these started at 4. We print out the value. Then we said incremented up once. We printed, that became 5. We printed the next one, that became 6. And then we incremented. We went negative on the next one. We decremented, and that became 5 again. All right. So let's go ahead and now back to our deck. All right. So the difference between prefix and postfix is that when you increment or decrement by themselves, it doesn't matter. If it's the only thing in the file, but if there's an expression going on or an equation, prefix notation, that means you got the pluses or the minuses before. That means that variable will be prior to the rest of the equation, will be incremented prior to the rest of the equation being evaluated, and postfix means it'll happen after the equation has been evaluated. And let's go really fast and look, and I can show you an example of that. So here we have, you notice it's going to print 4 things out. So it's going to print out the intro, numbers 5, numbers 4, then it's going to print this with the prefix, then with the postfix, then the prefix and the postfix. So when we run this, you'll see, run anyway, and starts at 4. I'll increment using prefix, so it becomes 5 right away, and now the number's 5. Now I'll increment using postfix, so it still is 5, and it doesn't become 6 till the next line. Same thing happens here. Decrements at 5 right away. Then this time it doesn't decrement to 4 until the second part. So prefix, if you put them in front, it increments right away. Otherwise, it increments backwards. Go ahead and we'll get back to our deck. All right. The for loop. Loops are a way of repeatedly doing a task. You want to repeat something multiple times, and you can just count them out. So we normally use like some kind of counting loop, and what's called a pre-test loop. That means we do the test first, then we see if it's any good. And the basic code is you put a for, and then inside first step you're going to initialize your variable. Second step, you're going to put your test, and your test is something like is my variable greater than 6? And if it isn't, then I can do my loop. And then update, this is where we can do our counting, okay? So in this example counting loop, we increment or initialize our number is 1. We ask, is the number less than or equal to 3? If it is, then you can do this. And then we tell it to increment the number by 1. So here we go. This will be 1. It passes the test. That means we get to go to here, and it'll print out 1. Then it goes, increments to 2. Again, 2 is less than 3, so it'll still print 3. 3 is equal to 3, so it's good. Print. Then 4, it's done. That's how it ends. So that's how your for loop ends once you go past the test. So if we go up here for another example to see, and bring up the counting loop here, and we've got this here. So we've got the exact same thing we just went over. So we have run the file and run anyway, and then we take a look at our output. And there it went 1, 2, 3. I'll show you if we can mess with it a little bit. Let's change this to, here, watch this. I can initialize this at 5, and I can make this 10, and you'll see how this works again. So run anyway, and I get 5, 6, 7, 8, 9, 10. So the basic premise is that your for loop, first thing is your initial value. Your second thing is your test. Is it less than or equal to 10? And then your final thing is you want to increment. I want to increment up. Or you could decrement, and then finally, inside the brackets, you can have your execution statement. And you can have as many statements in here as you want. You don't just have to have a single printout statement. In fact, very rarely why would you even waste your time just printing out a statement? That's just, So let's go ahead and pop back into the deck here. If you look at the flow chart for a for loop, you basically have a Boolean expression. That's your test. If number is greater than or equal to 3. If it's true, you do your statements, you push your update, and it goes back and does it again. If it's true, pop. If it's false, once you hit 4, it ends. It's just over. Okay. Sections of the for loop. The initialization section of the for loop allows the loop to initialize the control. The test section acts in the same manner and condition as the while loop, which you haven't learned while you loop says. Don't worry, the test section is your test. Is this equal to, greater than, whatever. And your update section for loop, that does last, and that does your increment or decrement. Loop initialization section for loop is optional, however, it's usually provided. Typically, for loops initialize a counter variable that will be tested in the test section. Initialization section can initialize multiple variables. Variables declared in this section have a scope only in the for loop. Okay, and that means that if you declare the variable in the initialization section, it ain't there anymore. So if you went back and instead of having number, you actually did declare it as, here. If I tried to print that number value out down here now, it's not going to say that's not a variable. It doesn't exist outside of that scope. So update the expression. That's the last part. That's our counter. The update expression usually is used to increment or decrement in some manner. The update section of the loop executes last in the loop, and the update section may update multiple variables, and each variable is updated as executed as if it were on a line by itself. You should avoid updating the control variable in the loop, and what they mean by that is instead of using a decrementer here, this number plus, you could have, and you'll see people do this, and it would do the same result. The number would keep adding. And the reason to avoid it is, number one, it's just hard to kind of maintain the code and makes kind of ugly. And the others, there's efficiency efforts. You're not going to see it in a small program, but in the larger programs, efficiency is the name of the game when it comes to a program like this. We can also increment by other numbers. So here, I'm going to count by 5. So I've got my number, another shortcut here is plus equals, and then the value behind it. So if this was 10, it would be, so at 5, it starts at 5, and it's going to go 10, 15, 20, 25, up until it gets 30, then it's going to stop. If I made this 10, it would be 15, 25, 35, So that's how that works. Which remember, it's just plus equals, and that's the incrementer for that. Nested loops. All right, so nested loops, much like your nested if statements, they execute inside each other. But the thing with the nested loops is, if we look here, for I is 10. This one's going to go 10 times. It's going to go, starts at 0, goes up to 9. This one too, starts at 0, it's going to stop at 9. But what happens is this one goes 0, first time through. This does all 10, 0 through 9. So that's 10 iterations. Then this goes to 1. This goes 0 to 9 all over again. This goes to 2, 0 to 9 all over again. So this loop statement is actually shown 100 times. You can look at an example. We have a clock example we can look at. And this one is actually somewhat interesting. We'll give it. So we're going to initialize the hours here. See, and again here, see these have all been called within the loop. So these variables are completely useless outside of the for loop. So we initialize the hours as 1, 12, greater than or equal to 12. Minutes, 0 to 59, greater than or equal to 59, because there is no 60 minutes. 60th minute going to become 0 again. And the same thing with seconds. And we just print out the results for each one of these. But this is going to go, this first loop's going to go 12 times. For each 12 times that goes, this one's going to go 60 times. For each 60 times this one goes, this one's going to go 60 times. So you got 60 times 60 times 12. So if I run this, and you're just going to watch this, okay, and just watch the bottom go. It's like kind of looking like at a slot machine. This is how many times it goes. So that's just the nested loop. And again, the whole point, the magic of the nested loop is the fact that, or the thinking about when you do them, that you have to keep in mind, because nested loops can become a bit much, is for each time this one goes, this is going to spend all of it. So it's going to do all of it 60. This one's going to do all of it 60. So keep in mind that, if you only wanted this to go 60 once, you don't nest it inside of a loop. It's going to go multiple times for you. All right. Now we have the break statement. So the break statement can be used to normally break a loop. Break statements bypass normal mechanism and makes it code hard. I don't agree with this. I use break statements all the time. So I think the code is fine. I think this is just, I completely disagree with the author on this. And the same thing with continue. The continue statements, and in fact, this they said it's just I don't really care. So I'm going to go and show you how this works. And I'm going to go to something I like called W3 School. And hold on while I make it so you can read it. Grab this and, all right, so check this out. Number one, this is a great place. You just Google, and they have all different languages, Java. But the cool thing about it is you can practice this stuff. So we have a break and continue. So here's a break statement. Let's read it. We start at 0. We're going to go up to 10. But here I've put in an if statement. I say if the I is equal to 4, I want you to break. And you're going to print out. So the great thing about Java, this thing is you get to try it yourself. So let's go ahead. I'll put the break back in. And I changed it a little bit because I was messing around before. Put the break back in. But I have an if I equals 6 now instead of 4. Same thing, we're counting to 10. I'm going to run this. Takes a second. And we'll see the results over here. 0, 1, 2, 3, 4, 5, and it stops. So if I set this to 4 and I run it, one, two, three. So it stops at that point. Now continue works a little different. Watch continue. But that's what it is. It breaks it out for if you hit an event, you want to end the loop prematurely because this event happens, Continue, watch this. So I set continue up. So the same code altogether, still going to 0. Now watch this. It goes 1, 2, 3, 5, 6, 7, 8, 9. So what happens is when the event happens, when the if statement happens, once you hit that on a continue, it stops. It immediately does not go any farther. It does not let you execute this. It just immediately goes right back, starts the loop again. So if I change this to 6 and we do this, Notice it skips 6. So break stops it, continue just stops that single point running and restarts the loop again. I think that's a much clearer way to look at it than the, I'll call it the gobbledygook they've got written here on the file. All right, so I disagree on that, and I think that's my statement. All right, so we're almost done. Random number generators. Again, with an API class, the Java API, there's a method called random we can bring into class called random. Classes have methods. We have to import it just like we did with our utility, just like we do with scanner. So import Java utility random. You initialize it random numbers equals new random. And then you have these methods here. One method will be next double. And that'll return anything between 0 and 1. Next float, 0 and 1. But you're going to have a bunch of decimals in between. So it'd be 0.2, 0.1, Next int, that returns the next random variable as an integer, which will be between negative 2 billion something and positive 2 billion something. And then you have this method here where you can give it a limit. So it's an integer with an n. Next int, integer with an n, and whatever n value I give. So this would be between 0 and, if I made this n 10, it'd be 0 to 10. If I made it 30, it'd be 0 to 30. Another option you can use is the math class, where they have a random method which returns 0 to 1, which is very much like a probabilistic way of looking at things. So if you were going to do a coin flip, if the math random was less than 5, you just could say that's a head. If it's greater than 5, you could say it's a tail, 0.5. Then you have what's called the POW method, raising a floating point number to a floating point power. So a square could be implemented as POW floating point number and then 2.0. That was squared. So that's the quick look at loops. See you in the next class. Thank you very much.